Good evening, and welcome to the latest economic series. And we have a pleasure to have Mr. Stan Marshall tonight talking about understanding Muskrat Falls. I'll give you a little introduction to Mr. Marshall in a second, but I just want to remind people that you're here as our guest, and as Mr. Marshall is, and we hope that people behave as our guest and respectful and courteous. Mr. Marshall will speak for about an hour. Then he will take questions from the audience for about a half an hour. Please keep your questions to about a minute or so. And for the media, Mr. Marshall's agreed to answer questions after that period of time down here in front. This is one of many kind of things that we do in the department. So next Friday, we're going to have a speaker come down and speak about marketing and regulation of marijuana, simply because it might be of some interest to people. And on the 7th of March, we have something called Forum of Healthcare Outcomes and Healthcare Cost, what we can afford, and that'll be an all-day event, and that'll be available publicly as well. So Mr. Marshall has kindly agreed to come and speak to us, helping us to understand Muskrat Falls, and we are very appreciative of him finding the time to come. Mr. Marshall is, as those of you who may not know, he's the CEO and president of Nalcor Energy, and he served on the board of directors and a CEO for Fortis in the past. He has a lot to say about Muskrat Falls and has a lot of knowledge that will help us understand that. We do these kind of things because we want people, whether or not you agree or disagree with the positions our speakers take or that we take, we want to do this because we think having more information is helpful in terms of making your own decisions about where you want to go to. That's our perspective on this. Mr. Marshall, I will stop here, but he's a member of good standing for the Law Society of Newfoundland and Labrador and a registered professional engineer of the province, and has been working in the energy sector in lots of different ways for many, many years. So I'm going to let Mr. Marshall give his talk, and he will answer your questions as we go through, and if we need to moderate, we'll moderate at that point in time. So please try to keep your questions to a minute. Mr. Marshall, thank you very much.
Thank you very much. I'm a retired member of the Law Society in good standing. I don't want to give the impression I'm still practicing law. Although the lawyers are doing very well with this project, I could have done better. So if you can all hear me, thank you all for coming. I'm sure you've all heard every day for the last 5 years something on the media about Muskrat Falls. There's always some article there. And as I've gotten involved in the last just under 2 years now, the thing that always strikes me is that the debate is about some small part of it, almost ad nauseum. And what I want to do this evening is try to address what I think is a great deficiency, and that is very few people, even from the beginning, have understood the big picture of Muskrat Falls. And you know, when I was a young boy, I used to love doing picture puzzles. You probably don't do them anymore. And so I'd get these big box of puzzles, I'd dump them out on the floor or on the table, maybe 2,000 or 3,000 pieces. And you see them there, little pieces in different parts of colors, and you wonder how you'd ever get them all together. And the thing that was absolutely essential to get them together in any short period of time was to see the picture in the box. If you didn't see that picture, there's no way to organize the little pieces and get them done. And so that's what I want to do for you, attempt to do tonight, give you a bigger picture. I know some of you have questions about little parts of it, and they have been exhaustively explored, let me assure you. The big picture, I seldom hear from anybody. So let me give it a stab. Now, most of you know what the project is about. Let me see if my pointer works here. So you start Muskrat Falls itself, the generating plant. Most of the discussion is about generation at Muskrat Falls. It is not the biggest part of this project. And that's the first mistake that was made. This is primarily a transmission project, totally lost from the beginning and led to a lot of problems. If you look at, in a lot of the discussion, for example, they don't include the cost of the maritime link, which, while it's being built by Emera in Nova Scotia, we are essentially paying for by giving free power, about 20%, 25% of the power from Muskrat Falls for 35 years. So in fact, we are paying for this. And when you add that into the total capital costs, as we'll see later on, there's no question in terms of dollars, it's primarily a transmission project, which doesn't add 1 kilowatt hour to our energy. It gives us opportunity, it's an important asset, but it's important to understand this because one of the first things I did when I came here was to recognize we had to separate generation from the transmission as a part of the project to get control of it. One individual was trying to handle it all, was totally overwhelmed. I split it in two. At the time I announced that, the media said, oh, cosmetics. It really was the secret to getting control of the project. Divided it in two, to recognize there are two entirely different projects, different skills required, different timelines, different factors involved. And as I'll show you later, we're on the verge of bringing the transmission line into operation 2 years ahead of the generating plant. So different components. Muskrat Falls, everybody knows about that. I'll talk some about that. The line goes back into the existing plant at Churchill Falls. We call that the Labrador transmission assets. And that was to ensure that anything that was generated here could be transported back and forth to Churchill Falls, the existing plant here, which itself is tied into the Quebec system. It has been for a long time. And we have had access through Quebec, approximately 250 megawatts of power, in agreement with them, and open access they have in Quebec. So we have the opportunity to export power through here. This project gives us the opportunity to export power through here, Nova Scotia, and onto whatever we consider to be the markets at this point. The Labrador Island Transmission Link, 1,100 kilometers of DC line going from Muskrat to Soldiers Pond just outside of St. John's. I'm going to talk about each one of these components individually, but I want to get a picture in your own mind of what we're talking about. The link to Nova Scotia, the maritime link, does not tie in with this directly. This starts at Muskrat Falls, goes to Soldiers Pond. DC link, there's a terminal station there, converter station, terminal station, converter station here, just outside the city. The Nova Scotia link goes back to Bottombrook and ties into the Bay of Spear system, which ties into the whole grid of the island, but is not physically tied together other than through the Newfoundland hydro system. So I'm going to talk about all these, get a picture in your mind: Labrador transmission assets, Muskrat Falls, the Island Link, Maritime Link, Muskrat Falls. A big takeaway from you tonight: we've had a tremendous successful year in 2017. When I came to Nalcor in April of 2016, we were in crisis, facing imminent collapse within months. And so you're in a chaotic crisis situation. 2016, a very difficult year. Occupation of the site, leaky cofferdams, faulty cable. The fact that the Stolly was going to go bankrupt by July, the main contractor. Someone used the analogy, I took over command of the Titanic after you hit the iceberg. I wouldn't go that far, but there are certain analogies to that. In that, when you're in that situation, you've got to focus on the immediacy, saving the ship. That was the only focus. No time to worry about painting the gunnels. Not only did we save the ship, we got our back on our own power, and we're heading for safe harbor. We have our challenges, but in the last almost year and a half, we've gone from a crisis situation to a very well-run mega project with its challenges, to the point that other people working on mega projects in North America have come to us to see how we did it. We did it with the same people. I flew back recently from Muskrat with some of our senior people, and one of them turned to me and laughed and said, "You know, I don't understand it. What did we change?" A lot changed. how things were organized, the approach to the project. The whole approach changed. But it began, as I said earlier, with the recognition we were doing with 2 projects, at least 2 projects. So as we finished 2017, we went through 2017, there was no interruption. No occupation, no interruption of any kind. The Stawley alone poured 130,000 cubic meters of concrete, about the same that went on the Hydro platform. We poured that in 1 year. Another more than 100,000 cubic meters of concrete went into the North Dam, which is now shut down for the winter, but it's within budget and ahead of schedule. Last year, when I gave my update, the big change was we had to go back and talk to all these contractors about the 2-year delay, all the claims that came back from all the things that had gone on in previous years. By the end of the year, we had resolved it with all the major contractors. Stawley, we brought forward to the end of 2017. In other words, they couldn't go back and claim anything prior to that. They had a very successful year. Andritz, who had been suing us, agreed to come back. We got together and decided how we're going to proceed. They're in, we'll see a picture later, they're now installing the turbines. GE, some of you know they're facing great difficulties corporately in the United States. We've been dealing with them. So we've taken care of the big ones. Now we still have some smaller ones. Some of them will have to go to arbitration. But right now, everything was within the budget I gave you back in June. Seems so long ago now, but we got a $2.9 billion additional loan guarantee from the federal government. That meant that our demands from the province were reduced by $2.7 billion. It meant that rates could be reduced by 1.5 cents per kilowatt hour, which offset the cost we had with settling with the contractors. In summary, as I stand here now, you know I gave an update last June. There's no reason to think that I should change that at all. We're within the parameters I talked about, both in terms of time and money. It was an outstanding year. It's a tribute to those people who worked on it, whether they're our employees, contractors, or Aboriginal partners. Everybody worked together. I say to them, your best defense in an inquiry is how you performed in 2017. You can do this. You've done it. You've done as good as anybody could, anywhere, on this project. And I want you all to understand that. Now, it's still a mega project. We constantly have these challenges, constantly dealing with contractors. Any day there could be some big issue come up. But right now, there's been no change in schedule or money since last June. So let's go back and talk about the different components. Power generation. Muskrat Falls, you hear all about. The smaller part of the project. I wanted to get this picture because it's the most recent one I have. It doesn't give you as clear a picture as some of the others I have later on, which are taken in the spring, because a lot of things are covered in snow. But I want to explain to you what it's all about. The first thing you notice is that the generating plant is covered in. Nobody thought we could have that plant covered in for the winter. It was covered in. They're now working inside on the generators. These parts are being covered up so they can work on the generators inside. These two are also covered up now. But I want to describe what this project is all about. So here's the Churchill River coming down. In this natural flow, it came down here through the upper falls, the lower falls, and came down through here. So up until 18 months ago, the water was coming down here. This is a rocky knoll. The North Spur is on the other side. I'll have a picture later to show that to you. The different components. There's an earth fill down here, which is finished now. You can't see it for the snow, you'll see it later. There's a dam here, made of earth, finished. Spillway, that's been in operation since about summer of 2016, late summer. The North Dam, shut down for the winter, now well out of the ground. Started last spring. Last spring we started with a dry riverbed. So it's out now, well up, as I said earlier, ahead of schedule. the spillway, generating plant. When you look at this, thing to notice, this plant, lower part of this plant, is actually more than 30 meters below the level of the river. Last year at this time, we were very concerned because we had diverted the river to the spillway. This cofferdam was leaking. We didn't have a boom across here. This is the boom. The purpose of that boom was, it has a safety attribute to prevent people from coming down into the forebay and going to the spillway. But its main purpose is to establish an ice sheet up here, which you see has actually happened here. It wasn't there last year. A very serious concern. Our concern was the water coming out here, without a stable ice sheet here, the water becomes super cooled. And when it goes up in the air and it's 30 below, it freezes and creates a natural dam of ice down here, which could have caused the water to back up into this hole. It would have cost us billions. So we had to spend extra money to put more cofferdam here and here. We were working on this cofferdam here to grout it in February. I was up there 40 below, putting grout into the dam. But we got that done, and it allowed us to start this dam first thing in the spring. Very crucial to all this. So this is 30 feet below the level of the river. The river is about an elevation, say 4 or 5 meters above sea level. As you see it there now, it's about, the water's been backed up just above the upper falls. It's been backed up about to a level of about 24 meters, 22 meters, where it's starting to build up, back up into the river and on the North Spur. People think the North Spur contains all the water. It doesn't. But half the head is from here to here before it even backs up into the North Spur. But this was a natural flow. It's been diverted. It allowed us to work here in the river this year. We've done that. We're ahead of schedule. The other thing I should point out, there's a lot of water going through this river. There's about 30% more that goes through the upper Churchill because there's tributaries downstream. But the head is very low. The head in the upper Churchill is about 1,000 feet. Here it's about 100 feet. It's about, when this reservoir is full, the upper level will be about here, and the lower level is right here. It's 100 feet. So when this is finished, this plug will be removed. The water will come up to about this level here. And the water will be coming in through here, through the turbines, and being discharged. So it's a very low head plant, very high volume, as contrasted with the upper Churchill. The flooding, very little. You can see the banks of the river very high on the other side. You can also see where there's been slippage, and there's basically sand and soil. This has been giving away since the last ice age, thousands of years ago. I'll show you some pictures downstream a little later. Very little flooding. The amount of flooding here in this project is about 1/60th of what was done in the upper Churchill. For example, the amount of metal mercury is proportional to the amount flooded, so it'd be 1/60th of what was in the upper Churchill. Nobody died from the flooding in the upper Churchill, and I expect nobody will die when we put 1/60th of the flooding in this one. Incidentally, there's been no case in the world over the last 2 years of building reservoirs where it's been demonstrated that anybody has suffered serious harm from metal mercury in building a reservoir. Get this picture in your head. Well, I'll start talking about some of this a little later. Now, so the capacity of this plant, there's 4 units of 206 megawatts each, for a total of 824 megawatts. That's the maximum it can produce. It won't be producing that at 24 hours a day, 7 days a week, 52 weeks a year. On average, it's going to produce 4.9 terawatt hours of energy. There's been total confusion between capacity and energy. There's 8,760 hours in a year. If you want to take that and multiply it by that, you'll say that at 100% capacity, it would produce over 7 terawatt hours. So on average, it's going to operate, say, about 550 megawatts. It'll operate at full capacity probably in the spring freshet, because, like I said, 30% of the flow comes in downstream of the upper Churchill, which there's no control on. The control is on the upper Churchill, And in the winter months, Hydro-Quebec wants us to run that full out, and then later on in the year we cut back. So that will dictate how we operate on a day-to-day, week-by-week basis. So just again to remind you what the Sanskrit number was, what the number I gave you last year, which is still the number I'm using. Remind you that initially, we're basically 2 years behind on the power, and also remind you that Emera is entitled to about 20% of the energy for 35 years because of the maritime link, additional 5% for the first 5 years. Basically, they're entitled, out of this 824, they're entitled to about 165 megawatts on peak. So when the power is at most, they're entitled to about 165 megawatts, and it works out about 1.4 terawatt hours. You should also note that this is not new capacity to the island. The first thing is that there are line losses. There's about 70 megawatts we lost from transmitting from the power plant to Soldier's Pond. Then you've got the 170 megawatts, 165, 170 megawatts you're going to give to Emera. And we're going to be shutting down Holyrood, which is 490 megawatts. So Holyrood, on average, produces, say, it has 490 megawatts. It probably produces 1.5 terawatt hours of energy on an average year. So we're replacing a thermal plant with a hydro plant. Net, you're probably only gaining about 100 megawatts in terms of capacity. You're going to gain a hell of a lot of energy, you'll see later. But there's only 100 megawatts of capacity, which limits the value of the energy you're selling because you can't sell it on peak normally. And it also means that we don't have this, while we have a lot of energy to sell, we can't be bringing in these big processing, what do you call them, the Bitcoin things, which operates 365 days a year, uses a massive amount of energy, but require the capacity too. We have to target what we're going to do with the excess energy to maximize its value. So what have we done last year? North Spur, we'll talk about later on. The work is finished on the North Spur. The South Dam, which I talked about earlier down here, you can see it here fairly clearly. There's an earth-filled dam, you can see the top of the dam, you can drive a truck across it, which you do now to bring over here. That's done. The powerhouse is enclosed. The boom has been put up for the winter and for safety things. The North Dam is 40% finished, ahead of schedule, and within budget. It's been a great year. Still, so overall, 78% complete. What we're seeing now is a transformation. Up to this point in time, the big focus has been these big outdoor civil works, pouring concrete, putting in big towers out in the swamps, stringing lines, blasting rock, moving soil, all exposed to the elements. The only piece left like that now is the North Dam, hang on, I better go back, which is, like I say, is not in the critical path, had a schedule, no problem. So we're transitioning from those big civil works out in the cold, exposed to the elements, to basically putting equipment, doing terminations, and testing things inside. Like in the powerhouse now, they're putting in the biggest part of that is putting together the turbines and whatnot. Yes, there's some concrete. We're working inside, even though it's, say, 0 degrees Fahrenheit outside, it's 10 degrees Celsius inside. And the other works is in the terminal stations inside. A big transformation. Our workforce peaked. We're going from 5,000, maybe down this year, we're down to about 1,200. The camps no longer needed. So now, just to show you what this is all about, this is the intake to the powerhouse. There's actually a big hole down here. They're still doing some work up here on the top, not in the critical path, where the gates, these are the gates which are closed and open here to let water go through the turbines. When the reservoir is filled, the water will probably be up to here. So you're looking downstream now, intake. Now you're downstream looking up. You're back where that berm was, protecting from the river downstream. looking upstream. So here you see the powerhouse, the spillway, up on top we're still working on some of the gates, South Dam. Here you can see where the water will be. When this berm is taken out of it, and this work is done, the level of the river will be about here. On the other side of the powerhouse, the reservoir will be up to here. It's only this is about 35 meters, a little over 100 feet. That's all we're talking about. Not a big head. A lot of flow. Now you're up in this rocky knoll. You're looking to the south. Here's the North Dam, which is shut down for the winter. You can see that they've come in. A little over a year ago, the river was coming down here. You built the coffer dam, poured rocks in the river basically, shut off the flow, and divert the water to go to the spillway. You see the water coming through here now. And the water came up. Here's the coffer dam. Here's the North Dam under construction. When this is finished, the water will overflow this, and this will be the dam up to this level here, up to the level of the spillway. So your North Dam, your spillway, powerhouse, South Dam. Now we're looking inside. This is inside the powerhouse. There are 4 units that I told you earlier. Unit 1 is here. You can see 2, 3, and 4. This is Unit 1. You're installing the liners into the spillway. The turbines will go about right here in this one. So they're working on all 4 now inside. It goes back and forth between the 2 contractors. Andritz, the turbine manufacturer, installs their liners and whatnot. Astolli comes back and pours cement, and they hands it back to Astolli. Back and forth, back and forth. But it's inside, under control. They're working on all 4 units. The North Spur. So here we are. We're looking upstream again. Here's the spillway. This was taken last spring, so the powerhouse wasn't enclosed. They're just starting to work on the North Dam, and here they're doing the remedial work on the North Spur. Here's the rocky knoll. Again, I remind you that the water level up here is going to rise about half of the distance here. So you're talking about, what's that? I think we're up to, right now we're up to 22 meters. We're going to go to 39 meters. Say 50 feet. The water we're retained behind the North Spur is about 50 feet. You can see, this was taken last spring. The remnants of the ice that had been built up. We got away without any problems last winter, but there was big, when we had the river open, you have these buildup of supercooled water, fragile ice, and the water would, this ice would build up 50 to 100 feet. And it could have flooded the works. It didn't, and now we're in good shape. So I'm going to talk about the North Spur. You're looking upstream now. It's a natural feature. You see we've done a lot of work here. We're on this side, on the other side. Now you're upstream looking back down. So here again, you got the powerhouse over here. You got the North Dam. You got the rocky knoll and the North Spur. You see that the narrowest point is here. This is rock. This is fairly wide up here. You see that the work that's been going on to put materials along here to reshape the contours of the spur itself. You get a better view from here. Now, so again, we're looking down south. You can see a truck right there. You get a sense of the thing. Also, you can see that along the river here where the bank has been collapsing over time. The one we had earlier in the week was around here. Nothing new. It's been collapsing for thousands of years. It had nothing to do with North Spur. It's been on the go. No problem. Nothing to do with North Spur. Nothing. I mean, the whole concept is the North Spur had to be stabilized because in its natural state, a lot of these elements are unstable. This work started over 40 years ago. So for at least 40 years, engineers have been studying this feature. There have been dozens of specialized geotechnical engineers doing studies. There are wells put in here to pump water to make sure it remains stable until now. And a whole groups of engineers designed the remedial work required. Very qualified geotechnical engineers designed it. It reviewed by another firm of geotechnical engineers. It was supervised by geotechnical engineers. The work was reviewed by other geotechnical engineers. When I came in the job, because there had been a concern raised about this, I went and reviewed all the work that had been done. I'm not a geotechnical engineer. I am an engineer. I know enough when I read it, the principle of what they're trying to do. I wanted to ensure, first of all, that they'd had a number of qualified engineers work on this project, that none of them expressed any concerns about design or execution, and that everything had been reviewed. Everything had been done properly. So you get one geotechnical engineer from Norway, voices a concern, okay? The rest of the world's out of the step except him. So recently what I did, after the latest words he expressed, well, again, the independent engineer was retained by the federal government to protect their interests, looked at this. We retained a panel of 4 PhDs in geotechnical engineering, including one from this institution here, to do a peer review of what this chap in Norway was talking about. We followed that review today. I saw it last week for the first time, so I reviewed it. It's on thing now. Basically, they say this guy doesn't know what he's talking about. He's not really familiar with the facts. Some of the suggestions he makes, in fact, would make things worse. The man, I know he's honest, but he's not really familiar with the terrain or anything else. And so these 4 people, experts in their field, reviewing the work he has done, says that, look, he's not there. So if you look at this, I'll talk about the components. So we've reshaped the spur to make it more stable. We've put materials along the banks, rocks, to make sure that it's more stable. What you can't see here, at the narrowest point, up here, we've put in what we call a cutoff wall, which goes from the rocks in this rocky knoll here, along here, over here. This is poured into place. They use big clams to dig down, and as they go, cement is poured into the hole. It's not intended to be totally like a big concrete dam. That's not required. What it does do is control the water levels in the spur to make sure that nothing can happen. A lot of work has been done. And this was taken during the year. This is what it looks like today. So if you're looking at it today, what you see? You can see all this materials is put in here to make sure that the level of the upstream will remain stable. You can see the outline where the concrete wall was put in along here and covered with impermeable material. And you get a sense of what we're talking about. So here, we're probably at, like I say we're at 23 meters here. The water level will only come up to here. This is 39 meters is about right here. So the water level will only come to this level. The difference between, say, 24 and 39. Basically 50 feet. Are we confident in this design? Absolutely. 100%. The other thing that people don't understand, dams just don't collapse overnight. In fact, I can't remember in my career a modern dam collapsing anywhere. But if you go back into the 1920s and earlier, before they perfected a lot of this geotechnical work, the dams that did fail showed evidence of failure for a year or more. In this design, what we have, the whole spur is monitored. There are wells drilled. There had been wells drilled there in case it was necessary to pump in some water, in case the water level in the spur got too high. They will be repaired and reinforced. And then we install meters that will remotely sense the pressure in the spur. So if there's any change in the water pressure within the spur, it will be detected. There are a number of things you can do. You can pump some of the water out, make sure that it doesn't endanger the spur in any way. In an absolute worst case, it ain't going to happen overnight. If you were detecting a very slow level of water in the rise in the spur, which you didn't want to pump out, in the absolute worst case, you bring the water level down, which would probably take, float level could probably come down in 2 days quite easily, because it's a very small reservoir. So nobody is going to drown downstream. Nobody. It's a totally modern design dam, latest in technology, and the panel we had reviewed this says that. You go online, read it, you use the latest technology, totally within everything that's experienced. This is not a unique, by the way, soil. It's very common throughout North America and in Norway. This is where the chap in Norway got it wrong. This is very similar to glacial deposits throughout North America and Scandinavia. So it's well studied, well known, well designed, well executed. I have no concerns about it whatsoever. Incidentally, when you're looking here now, these are the towers coming down from the upper Churchill, going across the river. They'll tie into the plant on either side. The island link, basically done. We're done. We're just tying it in now. We're in fact, what we're doing now is, energizing different parts of it with a hope that we'll be getting in first power by mid-year, maybe not full-time, intermittently as we start it up. These things are very complex. We're tying together a system in Quebec, a system in Labrador, a system on the island, a system in Nova Scotia. So we'll be bringing down this down the stream, one pole. The DC line is 2 poles, 2 big wires and a grounding station. We can operate with just one. But there are 2, so we'll start off at 1. We want to import power because what we want to do is save money by bringing power from the upper Churchill, cut back on Holyrood. We can save hundreds of millions of dollars before Muskrat comes downstream. The other feature here, Emera is part of the deal. They could put in equity contribution into this line. They put in about $600 million. Along with interest is $800 million. And they're entitled, with that investment, to earn a rate of return similar to what Newfoundland Power is allowed, which is around 8%. Very expensive financing as to the cost. I should add, when I came here, you got a whole construct of contracts, regulations, legislation that was put in place that didn't envisage early in-feed, because it's always assumed this would come on stream with the power plant. All that's in place, and now I want to save money by bringing it in early. We can do that, but it was never contemplated. So I'm operating in a bit of a void. We're running off to the PUB, who are not really having difficulty dealing with this. I mean, they realize there's money to be saved in cooperating. But what we really need to do at some point is go back and straighten all this up. At this point, I have to assume I've got to work with the contracts and the legislation making this in place. So everything I say hereafter is based upon having to deal with what's there. We've got to go back at some point in time and straighten this up. I think this is the last tower. You can see the tower is relative to the size of the people. These are huge towers. You've seen them going across the island. There's two main lines, DC, along with some grounding wires and whatnot, communications cables. This is the plant outside of St. John's, Soldier Farm. I call it my electric forest. You can see the vehicles here. This part here is AC. What happens is that the line from Muskrat Falls comes all the way down here, DC. It comes into here and it goes into converters to convert back to AC. These are solid-state converters, which means we have software, a lot of software, which is one of our big risks now. We have people in London or England right now, as they speak, working on this. Software risk, a big risk we face in the next few months. Will the software work? We've been doing a lot of work on it, but you see how our risks have changed. We're no longer worried about working out in the snow and the rain. We're working inside, terminating things. We're working in offices, getting billing software. So power comes in, goes through the converters. There's 2. Everything is in duplicate. 2 poles. We're going to start operating in 1. It comes in as a converter to AC. This is the high voltage AC area. These are synchronous condensers. These are basically just like turbines that keep turning around. They're like flywheels. Electrical flywheels, in a sense. They provide the momentum to keep the system stable. We're also going to use at least one of the units at Holyrood as a synchronous condenser to provide more stability. We might even get two. But they're not going to generate energy, you're just going to keep spinning around and give them what's called reactive power and stabilize the system. Not only is this finished, it's energized. So all the lines coming from Beta Spare, Western Avalon, from Holyrood, are now coming into here and are coming into the city. This has been turned over to Newfoundland Labrador Hydro. This is a control area here. This is operational. This is being finished as we speak. This is a similar unit at Muskrat Falls. What do we have here? The power coming down from the Upper Churchill, coming in. The power coming from the Muskrat Falls itself, going into these switching controls here. Gas insulated switchgear, they call it. See you later. It's conditioned. It comes into the two converters. Big transformers. These are the transformers we had to bring in last spring, but nobody said we were ever going to get them through Cartwright. Came in, no problem. We had to wait a year. Great cooperation from our First Nations people. We're working well together now. So the power comes in, is converted to DC, 350 volts, and is sent to Soldiers Pond outside of St. John's, going across the streets of Belle Isle. Again, we're in the process of energizing and switch these areas. Going back to the connection from Muskrat to Churchill, again, this is finished. What we did actually last fall, we weren't ready to energize the whole thing, but the old line going from the Upper Churchill to Goose Bay was falling down, and we jury-rigged part of this line to feed from Churchill down to Muskrat Falls, and we're actually using it to feed into Goose Bay, and we're going to, as you'll see later on, we're now going to, in the future, feed Goose Bay from Muskrat Falls. Again, the numbers I gave last year, still valid. This is the switch yard up at Churchill Falls. This area up here is where the existing high voltage lines, the 735 kV AC going into Quebec. We had to tie in that system, bring it over here, convert it to the 315 kV we use on the line going down to Muskrat. You see the towers going down here. That's, again, we're in the process of energizing this now and starting it up. Maritime Link. It's being built by Emera, and it is, I won't say it's finished, because we tried to use it the other day and they had trouble with some of their machines, because we wanted to start bringing power in now. We want to start bringing power in now from Nova Scotia. Again, to save money. They have coal-fired plants. They can generate a lot cheaper than we can using all Holyrood. We have an agreement that we'll bring the power in and split the saving until, as long as we need this. So, but right now they're in a startup phase. Some of their equipment has to be replaced. So it'll be another week before we can do that. But within a week, we'll be buying power from Nova Scotia and saving the money. This is a 500 megawatt line. There's two cables, 250 each. I'm going to have to speed up. This is a chart you have seen last June, reflecting the costs. This is the original estimate. Apples to apples comparison. Sometimes they didn't include interest during construction. This is the interest costs. This reflects the delay, 2-year delay. So we're comparing 6.2 to 10, 7.4 to 12.7. I neither had the time nor inclination to go back and find out what the problem was before I came along. I do know enough, and it's my position, not a proof, but I'm telling you now, it was never going to be built for this. Never. In fact, I would say that if you were starting today with the perfect knowledge we have, it would probably close to this, even with the cost overruns. So you're probably getting what you paid for. You may have done, if you had perfect knowledge, maybe you did it a year earlier. Maybe you could have saved $1 billion. Don't know, 10%. The fallacy is it was never going to be built for this. The problem is not the cost overrun. That's the first thing you need to understand in the big picture. You see the different components here. This is Muskrat Falls, Labrador transmission, level and feed interest. On this sheet, I don't have maritime link, because right now it's being financed by Mera, but that would be 1.5 billion on top of this. So even on this get-go, you see that in dollar terms, transmission is more than generation. In the scientific method, if any of you study science, you know the scientific method. You start with a hypothesis. I study science, I'm an engineer. You're trying to prove something in science, you say, okay, let's observe what we know. Let's put a hypothesis in place and then test against the hypothesis. And as we discover something different, we'll revise our hypothesis. So for the inquiry, and for all you folks, this is my hypothesis. I'm very confident in this. I haven't gone back, but I've seen enough. I said this in 2 months of coming into Nalcor. Almost 2 years later, I have no reason to change it. What's the problem? The problem are the original estimates were wildly optimistic. The risks were underestimated. Risk has impact on costs, but also time. No question, a lot of the contractors were not used to working in our environment. They're good contractors. Stolly is a world-class contractor. He had never worked in this environment. He had built hydro plants in South America and Chile. And as we've seen this past year, once they got the experience, when they got the right people working together, we achieved remarkable results. Nobody could have done better than the Stolly this year. Nobody. Then the poor execution. Again, we all talked about this dome and everything else. Yes, that was a fiasco, a reflection of some of this. But you know what? They paid for that. We paid for it at the time, but when we revised these contracts to complete it, one of the principles I said, it took a long time. We started off with a Stolly, we've done it with the other contractors. There's 2 basic principles. I said, it took 3 years to dig this hole. Don't think you're getting out of it anytime soon. That's one. The second principle was, we're going to share the pain. I'm sharing the pain, the people of this province are sharing the pain, but you're sharing the pain too. And it took time to establish that, but they did. And it's true of some of these contractors have lost hundreds of millions of dollars on this project. So if you've got an image of people at Nalcor or contractors going with little black masks on with bags of money, forget it. When a project like this goes bad, almost everybody loses, except for lawyers and accountants. And they're doing rather well. There's been more studies, there's been more inquiries, there's more supervision on this than I've ever seen. I have about 7 separate boards of directors. There's so many of them, I had to bring them in an auditorium like this and just give one presentation. Otherwise, I spend all my time talking to boards. And then we have the Oversight Committee, the Environmental Assessment Committee. We have ministers coming in. We have civil service coming in. This has been the most over-governed project ever. And you know what? Everybody focused on those little pieces. Nobody saw the big picture. Nobody. Nobody suggested when I came in, we were going to split this project in 2 for better control. Nobody. Nobody suggested to me we should get the transmission line back on stream so we could make money for 2 years before Muskrat come on the stream. Nobody. They were focused on those little pieces with their microscopes on. That's the big picture. And now we have an inquiry. I always knew it was coming. It had to come. The day I went in there, it had to come. I mean, you couldn't have a fiasco like we've had without having an inquiry. Well, my hope was always we'd have it after I was finished, because the last thing I need is more people coming in for explanations. Now I've got all my key people distracted about what they did 2 or 3 years ago, rather than being focused on what they should be doing tomorrow. But look, I understand this, the real world. But you have to understand me too. Yes, I'm as interested as you are in finding how all this came about. But my task is to get the job done. And that, by God, that's what I'm going to do. When you did all these studies about these things, one of the things you're worried about is what are the requirements? How much energy do you really need? So people are doing studies for 40 or 50 years. Can you imagine? I can't predict what energy load is going to be 2 years from now. But you got to assume something. Well, they assumed something. The assumptions were reasonable. But you know what? You dropped about 80 terawatt hours. As you'll see later, if we're going to collect the cost of this thing based on energy, now we've got fewer kilowatt hours to spread it over. So one of the assumptions has been this, now it's down to here. So what does all this mean? What I'm talking about here is the deliveries of energy from Muskrat Falls. So this is what hydro needs to serve the people on the island, bottom one. This is what Emera is entitled to, this one. First 5 years is different than later on. Just concentrate on this. And what happens in years out there, we'll worry about then. This light blue is what hydro initially thought it wanted to serve, needed, but because of that drop in load, we now have to sell in the open market in addition to what we always thought we had to sell. So this is what we actually need. About 1/3 of the energy from Muskrat is what we need. 1/3. About 25% goes to Emera for building the line, so no revenue there. Then we got 40% to make up. The big assumption that went wrong here, another big assumption went wrong. And I've said all this before, by the way. This is nothing new. I said that the big assumption in the Upper Churchill was the energy prices back in the 60s, which were low, would stay low forever. That was the big fallacy, the assumption in the Upper Churchill. When this deal was done, the underlying assumption that the high energy prices of 7 or 8 years ago, which were high back then, not only would they remain high, they would continue to increase. Which meant that as you went to sell this energy up here, you would make all kinds of money. Energy was selling about 7 cents a kilowatt hour, going up. So where's energy today? We probably net 2 cents a kilowatt hour today. No prospects of going any higher because of cheap natural gas in the United States. You got natural gas, you make electricity. So we made the assumption energy prices are going to keep going up, they've gone down. You built something 3 times as big as you needed. You leveraged. You bet the prices of the sell the other 2/3 are going to go up, and went down. The analogy would be you need a new house. Your mother-in-law is going to move in. You have an option. I'm going to do my basement, build my house. But you have a great idea. Housing prices have been going up. You say, okay, what I'm going to do, I'm going to build not one house, I'm going to build 3 new houses. And I'm going to give one to the contractor to build then I'm going to sell the 3rd one and make all kinds of money, and I'm going to be great. I speculate, instead of housing prices going up, housing prices collapse. Now you're stuck with 3 houses. You speculated. You didn't need to do it. And that's where we are today. When I came here, I was 2 years ago, I said, how do I convey this to people? You don't understand billions of dollars. Billions of dollars, you don't understand. You don't understand megawatts, gigawatts, terawatt hours. People don't understand that. What they do understand is kilowatt hours, cents per kilowatt hour. So I came up with this methodology. This is exactly what I gave last June, how to make people understand what this is all about. So I translated that all into cents per kilowatt hour. So you look at the first pie chart. The purple represents the cost of generation at Muskrat Falls. It's 7 cents a kilowatt hour. So if everybody was buying the power at the bust in Muskrat Falls and paying the same thing, they'd pay 7 cents a kilowatt hour. A bargain. If someone could build a hydro plant and level out your costs for the next 40 years, say it's going to be 7 cents a kilowatt hour, you'd take it. So the problem here is not the cost of Muskrat Falls. It's a very attractive plant in its own right. Even with the cost overruns, the price of energy at Muskrat Falls bus is very attractive. But, as I pointed out earlier, you got a transmission system, which in cost terms is bigger than generation. And you got two, you got the Labrador infeed, you've got the Labrador transmission assets. So power that costs 7 cents on the bus in Muskrat Falls, brought to Soldiers Pond outside of St. John's. If everybody's going to buy the energy now and pay the same price, you're all going to pay 17.5 cents outside of St. John's. Well, if I could take a 17.5 cents, I'd take it. That's not bad for next levelized price for the next 40 years. I mean, we're paying, right now at the Holyrood, we're probably paying 13 cents for fuel. Not bad, right? Now, that's made up, you look at it a different way, where's this cost coming from? You got the depreciation to pay for the assets, you got the interest payments on the loan, you got operation and maintenance costs, you got to pay Emera for the investment on the Labrador Link, and you got a little bit of profit here. That profit, by the way, the province has close to $2.7 billion invested, about $2.7 billion of equity in this thing. So you need that to give to the province just to pay the interest on it. Yeah, it's profit here. I mean, say from Nalcor. Now, there's a public policy thing to be made by the province. How much is going to be they're going to take in dividends? How much are going to use subsidized rates? But that basically was just enough to cover the interest to the province. Okay? So now we're up to 17.5 cents. Okay? We're all going to buy power at Soldiers Pond, 17.5 cents. But don't forget, the Newfoundland consumer, the internet connected consumer on the island, is going to get 1/3 of the energy, but is going to pay the full cost. So the 17.5 cents had to be multiplied by 3, because Nova Scotia is not going to pay the 17.5 cents, and we're only going to get about 2 or 3 cents by selling the rest of it, which is pretty well nothing. So if Newfoundland consumer is going to pay for it all, but only get 1/3, the Newfoundland consumer is going to pay close to 50 cents a kilowatt hour. That's the problem. It got nothing to do with the fact that this was a really expensive generating plant. Yeah, it didn't help. It had cost overruns. But you got a contract that bound you in for at least 35 years, and you're stuck. So what does this translate into? So when this thing was sanctioned, this was the estimated costs. Don't forget now, when Hydro is going to take the energy from Muskrat Falls, but it's got all their cheap sources on the island, so it all gets blended in, and Newfoundland Power got to get its costs paid. So when you add all this up, this produces a rate of around 22, 23 cents, which is what I said the first year I was here. Changed a bit because we got the federal loan turning, brought it down. We had a cost increase, certainly the contractors brought it up, but basically back where we started. Don't worry about this out here. Where's my pointer gone? It was assumed that Nalcor would make more profit in the future. This is all pipe dream stuff. So, when I took the job, my mandate was to do 2 things. Bring Muskrat Falls under control, bring it to a good finish. Do what we can. There's no question we had to finish it. We were about 80% committed. You just can't go back and say, oh, don't let my contract, give me all my money back. Even if you did, you're still going to replace Holyrood. You had to finish it. There's no other way of getting through it. So, what do we have to do? We had to get more money. Federal loan guarantee. Otherwise, the province is going to go bankrupt, really. That was done. We're now working on bringing transmission, in-feed, in the vast of Muskrat Falls. You know, we can save maybe hundreds of millions of dollars between now and then, depending on energy prices here, energy prices in the Maritimes, bringing in the power. See, we're selling the excess power from the Upper Churchill. We're only getting about 2 cents net by the time we pay Quebec. Energy prices collapse. So we're getting 2 cents per kilowatt hour. Fuel at Holyrood alone is costing about 13 cents. So we can save more than 10 cents a kilowatt hour for every kilowatt we bring in. It adds up. Then, notice we're targeted. Remember what I said earlier, we don't have a lot of capacity. So we have to find customers whose needs match what we have and maximize the value. Not only that, but we want to bring in, like we're going to do next week. Right now, Nova Scotia generates electricity cheaper than at Holyrood. You're using coal. We'll buy power from them, displace the oil. So instead of using that linked export, we'll import. And we're going to be buying power as well as selling it. I mean, look at Ontario. Because their nuclear plants are based, loaded, you can't just turn back the dial on a nuclear plant. If at a given moment in time they don't need that power, actually Ontario pays Quebec to take their energy. They pay Quebec to take the energy. Quebec backs off its hydro plants, this reservoir, and gets paid for taking it. We have access to some of that too. We have, don't forget, we have a 250 megawatts through Quebec, and we have been talking to Ontario. So we will be trading power if we get this regulatory, contractual construct sorted out. And we will. So where are we? 2018. What do we want to do? Remain safety focused. Haven't spoken about safety. You know what? This project has been outstanding, the safety performance. Absolutely outstanding. Long before I came along. Right from the get-go, this was safety driven. No fatalities. The culture at Nalcor is outstanding in safety. Has been. Always, this is the first thing we can think about. So we want to maintain that. Then we want to complete the transmission line and have them energized, basically one pole operating intermittently by mid-year. We have our challenges, but right now we're on track. Generation, again, safety focused. We want to install those turbines, the generators, for 2019, first power 2019. Don't forget now, the way the contracts are written, Newfoundland gets the benefit of the first 2 units, total economic benefit. Nova Scotia only starts to get the benefit when the 3rd unit comes on. The 4th unit is almost basically, backup. So the first unit is very important to us. What I had tend to say, I'm going to cut off because of time constraints, but I try to do it as I went along. But I hope by now, you're starting to see a big picture. And when I said, you look up the definition of boondoggle on Wikipedia. It uses my quote as an example. Man, you've made it. You really made it when you're used by Wikipedia as an example in a definition. So, is Muskrat Falls a boondoggle? If it is it because of the cost overruns that everybody's focused on? A boondoggle doesn't require a cost overruns. Boondoggle is a thing which is a big project behind schedule, usually driven by public policy with no economic advantage. There's benefits to this. The problem is not really the cost overrun. I think you see that now. The problem is the construct, the contract it was entered into. I spent 40 years in the utility business. The fundamental principle, electricity is essential to our society. Because it's essential, your mandate is to provide electricity very reliable at least cost. That's what your focus is. Was this developed to do that with this construct? Or was this a public policy decision? If it was a public policy decision, and it's perfectly valid for our government to say we want to develop a resource because they're going to create jobs and positions for the future, make us an energy warehouse, to exclude the PUB. PUB doesn't have the right to be that public policy thing. This is a public policy, broader public policy, what politicians have the right to do and should do. Maybe it was done for that reason, which that's fine. You can't argue with that. We elect governments, they make decisions, civil service execute. If it was done for that reason, fine. If it was done as a public utility exercise, then you have serious trouble, because this was never going to meet that mandate. It's very difficult to make projections for a year. A lot of us now have made projections for 40, 50 years. The thing you do when you make those type of projections, you're not going to be wrong, right? You know you're going to be wrong. So the question becomes, what flexibility do you give yourself to respond when things change? When you lock into long-term contracts with others, you have no flexibility. If you build something for meet your own immediate needs, if you built the one house instead of three, you wouldn't have been exposed when the market collapsed. So as I said, the assumptions in Muskrat Falls, that high prices of oil, electricity would go on forever, the demand for electricity in this province would keep on rising. Of course, when the prices collapsed in the United States, everything was set up for the boondoggle. The project was too large for our needs. We took an enormous risk. This is a huge compared to the economy in Newfoundland. So we speculated and lost. So rather than become the answer to a problem, Muskrat Falls became the problem. It was not the fault of the people who were called upon to execute, although there were problems in execution, no question about that. To a large measure, the contractors have been called upon to bear the burden of a lot of that, and you're basically getting what you're paid for. Things change. It doesn't have to be a boondoggle forever. Sydney Opera House was called a boondoggle at one point in time. No longer viewed that way. There's things we can do to mitigate the cost of this. There's other advantages we can achieve. In 20 years, the upper church will come back to us. The skills we are going to acquire now with high voltage DC, all these controls, all this experience we'll have with the cables will be useful when that happens. Gives us more options. So don't despair. We're making progress, making real progress. But it's a marathon, not a sprint. And for goodness sake, stop focusing on the minutia and look at the big picture. So in closing, mega projects. Sometimes I express as 5, sometimes as 6. If it's government, you can sometimes talk about 7. I'll come back to that. A mega project starts off wall enthusiasm. Can you remember that? Big announcements, followed by endorsements from everybody. It's wonderful. But then comes disillusionment. Reality sets in as forecasts and budgets go out the window. This starts before the first spade goes in the ground. Then third, confusion, panic, hysteria. Who are you going to call? Whatever happened to Sound Marshal? Anybody got his number? Fourth is the search for the guilty. Who's responsible for the boondoggle? No one's going to admit it, not me. That's where we are now, right? So going forward, we can look at steps 5 and 6. Number 5, the punishment of the innocent. The people who created this and were responsible are long gone. So let's punish those who are left trying to correct the problem. And finally, phase 6. After the project is finished, it's time to reward the uninvolved. Or as Dr. Bruno, my former boss, and who this building is named after, used to say, the adoration of the uninvolved. Everything that could be done to fix the problem has been done. Bring out the carpet, hang the banners, lights, cameras, we're done. Except if you're government. Government sometimes has a 7th phase, which is because governments have an inverse learning curve. When they make a mistake, the conclusion is, we couldn't possibly have made a mistake, we better try all this again. So, questions? I still got a few minutes.
We have some microphones. You want to ask your questions, put your hand up, and somebody with a microphone will come get you.
Okay, I'm going to start this one out with some key assumptions from Muskrat, which were $135 per barrel of oil going on for 50 years. What else was there? Making wind power illegal. There was a number of steps that were taken with Muskrat that passed the bounds of credibility and go straight into what appears to be fraud. Now, where did I drop that to? The question I have for you guys is, because it's not just you, we have the previous management, we have the PC party, we have the Liberal Party, and I'm wondering if you guys understand that a person who willfully and knowingly poisons an entire population, puts thousands of people at physical risk and risk of death, and destroys the future of a province, based on what appears to be long-standing and systemic lies, may fit the textbook definition of what used to be called a sociopath and is now called an antisocial personality disorder.
What's your question?
Do you understand that? Like,
I understand what you're saying, but what's the relevance?
Well,
there's no relevance to this project.
Not say there's a fair amount. What's that?
We're not poisoning anybody or putting anybody in jail.
The Harvard study suggests otherwise.
Thank you for your question.
Anybody got a real question? Sure.
Oh, I'm sorry. Real questions about your guys' states of mind when you talk about the province?
Thank you for your presentation. Mr. Marshall, you said not one fatality resulted from this project, but I can think of at least 3. There was one on the West Coast and 2 here on the East Coast after a line collapsed. So just wonder if you can speak about those. Were they different parts of the project? Is that just a confusion? And if you're wrong about that, what else are you wrong about?
No, I'm not wrong about that at all. 2 fatalities were on line 267, line from Beta Spare to Western Avalon. They're not part of this project. And the other part was on Amera's line. So they weren't involved in our line at all.
One was the Maritime Link, right?
Maritime Link, yeah. But they weren't on this project.
Muskrat Falls, that's a separate project?
They're separate projects, yeah.
But it is related to Muskrat Falls.
Yeah, but I mean, I'm pretty clear that we're talking about Muskrat Falls here.
So the safety record isn't quite as good as you say, though. I mean,
The,
if you separate.
the safety record in this project is, in that international terms, for the project side, outstanding.
We've had 2 deaths.
Yeah, but it's on our work, but not at Muskrat Falls when the lines come into Labrador. We have 2 questions over here.
You mentioned the cost could be 50 cents a kilowatt hour for Muskrat in your presentation, 3 times your 70.
Yes.
Could you expand on that?
I thought I did. What happens is that the power from Muskrat alone is 7 cents. When you pay for the transmission, it becomes 17. And because the Newfoundland consumer is taking 1/3 of it, but paying for it all, you multiply it by 3. So that's what, in fact, the Newfoundland consumer is paying from the energy from Muskrat. That's not what the Newfoundland consumer is going to pay because it's going to be blended with other costs. When you get it blended with other costs, it's going to be around 22 cents. Now, we're trying to reduce that. That's our mandate. We're going to do something there, but you can't, because of this construct, you can't change the big picture. We'll chip away at it, do what we can. But, you know, it's a contract. You built something 3 times as big as you needed.
Thanks. I've heard that the monopoly legislation that was put in place for the sake of the loan guarantee is in conflict with FERC regulations governing energy trade in the U.S. Can you tell us a little bit about that? Is that a worry for you? Is this going to be resolved?
Can you repeat it? I don't follow you.
The monopoly legislation that was put in place by...
Yeah, the monopoly is that no one else could sell to Newfoundland Labrador Hydro, generate and bring it in here. Let's make sure you, look, if Newfoundland consumer is going to pay for it, if somebody else is going to come in, the Newfoundland consumer is going to pay for this. You're going to pay for it, I'm going to pay for it. Are you going to make it worse by allowing somebody else now to come in with cheaper energy and add to your problem? We got too much energy, and we're trying to sell it. Now, are we going to let somebody else come in because we're stuck with this construct at a high price? And it gives us more energy, we've got to sell it at a low price. So we end up buying power, say, at 7 cents, and selling it at 2.
I understand that's a troubling possibility, but I've heard that FERC requires that we be Newfoundland Hydro
Well, see,
be
the
open
whole
to.
construct was there to underpin provide security to the lenders to make sure they got paid, right? That's what all this is about. That's why the contract was in place, that you had to do this, nobody else could interfere with it, because the thing was very difficult to finance. I mean, you couldn't have financed this without the federal loan guarantee. It couldn't have been done.
So you don't see any conflict with FERC regulations and this monopoly legislation, as some
No.
people have said in the media?
It's not a conflict.
Okay.
Mr. Marshall, you made no reference to water management. There was no reference to demand compression as a consequence of the, of rates hitting 17 cents plus. In particular, you referred to enthusiasm primarily in the context of the original estimates. Now, enthusiasm is typically not something that engineers would ascribe to pretty detailed process and sign off that would be conducted over a lengthy period of time involving probably a good many engineers and probably reviews at the executive level. Do you really ascribe enthusiasm to the original project estimates?
No, I didn't use that word in that context. I said, when I talk about the phases, well, enthusiasm, I'm talking about not the engineers who were working on this, but the people who were making the announcement. There's a bit of humor here, too. Don't get too deep into this.
Well, we're not laughing anymore.
Always keep your sense of humor, or try to anyway. No, look, the engineers worked out a long period of time. There's an interesting article posted by today, Ed Holt. You might want to read that.
Okay. Where did we find that article?
I saw it on, where did I see it? Ed Holt's blog? Reference there, yeah?
Yeah, Sir Robert Bond.
Yeah, Sir Robert Bond papers, yeah. He's making recommendations for the inquiry, talking about some of the stuff. The real question, in all this is, what was a political decision? What was an engineering utility decision? I don't know. But that's going to be core to what the inquiry has to discover, it seems to me. I think that's the point Ed was making today. I mean, this didn't start in 2010. People have been looking at the development of Lower Churchill since they built Upper Churchill. Go ahead.
Stand with reasonable estimates of demand elasticity for electric power. Is there any likelihood that we're going to find ourselves in a situation where we got a big power plant in Muskrat Falls and no demand for that power whatsoever? What assumptions have Nalcor made with regard to the demand for electricity? Because what I've seen a number of estimates from other jurisdictions. There's some research been done in Newfoundland, not yet in the public domain, but it suggests to me that demand elasticity is such that if you get a doubling of prices, what's going to happen is you're going to have a massive collapse of electricity demand, so that instead of 7 terawatt hours, we could be facing a collapse down to 4 terawatt hours. How can we deal with that kind of a situation?
We are trying to deal with that. The first thing you do is try to truly mitigate the costs, and build up a pot of funds that you can actually phase in the increases. Electricity rates are rising. I mean, you talk about 22 cents, looks outrageous, but Nova Scotia is already up to around 17 cents. Ontario, if Ontario were facing the full cost of electricity now, they'd probably be there already. So, electricity rates are rising. When we did the analysis there, I think we were assuming that, prices around 78 cents kilowatt hour. So there is a price elasticity, no question. But I think we're going to have to phase in this increase to avoid disruption. My experience over the years, different jurisdictions we operated in at Fortis. I mean, I saw prices as high as 50 cents a kilowatt hour in the Caribbean. Yes, the big thing to get people is sudden changes. People learn to live over time, and rates are rising everywhere, except in the United States, because of the shale gas. But in Canada, because of misguided public policy, like say in Ontario, big time, rates there are rising, and they're subsidizing rates. And that can't go on forever. So rates are rising everywhere. I think a reasonable target for us is rates comparable to maritime Canada. There's things we can do to mitigate. There's things we can do to phase in the increase. And we still have time to do some of those things. We're working on them.
Could I ask a question about the North Spur?
Yep.
I wanted to ask you, what does due process look like in your eyes? You have talked about this Norwegian expert, who happens to be a Swedish expert, and there's not just one of them, there's at least three of them. But when you talk about due process, you talk about an expert panel that you have appointed. And that expert panel has decided they're going to put out a 3-page paper within the last few days, basically telling the world that these Swedish people have no expertise. They haven't had an opportunity to come and speak across the table. I mean, I have a background as a chairman of a quasi-judicial board, and what I like to see is I like to see independent experts who are not hired by the proponent, and I like to see cross-examination. I like to see these Swedish experts being cross-examined so they have an opportunity, so they're not marginalized. They're not marginalized. So when you talk about the fact that you may have all the confidence in the world that the North Spur is safe, and you have more engineering expertise than I have, but I don't take your word because I don't believe in your definition of due process. And what I would like to do is I'd like to sit in your office across the table and talk about due process as it relates to the North Spur.
You've been in my office twice. My office, I've always had an open door policy. Everything has been examined by so many people. Everything we're not going to do is not going to be gone before some judicial inquiry and analyzed. We have highly qualified engineers there, as we did in design of the turbines, the generators, every other piece. I see no difference in it. Your man is one man out of step, so be it. Now, if you want to pay for it, go right ahead. My task is to try to keep the costs here under control, which is very difficult when everybody wants to study everything else to death. Where do you stop? What's reasonable? When you got 4 highly qualified PhDs in this area reviewing it, familiar with it.
But they're your PhDs.
Look.
They're your PhDs.
And we are paying for it.
Yes.
We're going to pay for it anyway.
And when you want more to come in, now pay for it. And I'm going to pay for them. You're going to pay for them too. So they're always going to pay. Does that make them professionals biased?
What is due process?
David, there's another question at the back.
Another
David.
question.
Phil Hellwig's my name. Can you hear? Is it working? It's working? Okay. My name's Phil Hellwig, and I've been working in the power business for at least as long as you have.
I don't see you.
When I saw the first discussion in the paper about the North Spur, I was quite concerned because Gilbert Bennett, who was reported on, was giving the information, didn't seem to appreciate the problems that could arise with sensitive clays. My advice at the time was that Nalcor should hire the best experts in the world to support them on this design. I also asked that these people be introduced to the public, that we know who they are, what their backgrounds are, and I was hoping that we'd have a chance to hear them talk in public. Nalcor has never given me the courtesy of naming these people in public. You talk about experts, who are they? Experts have names,
Yeah,
they have reputations.
Are you talking about the North Spur report, peer review?
I have followed it off and
It's on
on.
our website. The names are there.
I've asked that the names be made to the public, and I was hoping that it would be done in the Evening Telegram, as a matter of fact. I know who the names are now, but that's not the point. I think the point is that there'd be a lot more confidence in what Nalcor is doing if you are more frank in explaining to the people how you approach these things and who you've engaged to help you along the way.
I can't see how I'd be more frank than I have been here this evening.
Question in the center there.
Some questions over here. Here too.
Hi. First of all, thanks, Wade, for the Department of Economics for organizing this session. It's fantastic, so thank you for doing that. And thank you, Mr. Marshall, for offering yourself to the public like this. I think it's important in a democracy for public servants to answer questions, so I appreciate it. When you took over the role, did you think about canceling the project? And if you did and didn't cancel it, what would have been the reason? Would it be because you thought the project was still good going forward? Was it because there was kind of a poison pill involved? There were too many contracts signed, you couldn't back out of it, or there were loan guarantees? Why would you have continued with a project that you thought was very difficult?
Well, that was a possibility I considered when I came into it. But when you consider that Holyrood has to be shut down, you need something to replace Holyrood, first of all. You need something. You've committed to supplying Nova Scotia with 160 megawatts of energy for 35 years. So you got to replace Holyrood, you got to get energy for Nova Scotia. You look at the contracts that have already been signed for all these things, and so you're committed to paying about 80 to 90% of the cost anyway. So if you cancel it, that money was total loss. And you had to start over and do something to replace Holyrood, something to supply Nova Scotia for free for 35 years. So it's pretty obvious. You had to finish it. No question.
We have time for about 3 more questions.
There's some up here.
Hello? Mr. Marshall, you've talked about the economics and you've talked about how great this project is, but I have to ask you, have you considered the ramifications for the people who are living downstream, the people who are constantly living in fear, not sure what the North Spur is going to do, or is it going to move, it's going to stay put? What have you done to reassure these people downstream that their lives are not going to be in jeopardy? The other thing is, the other question I had was, I would love for the public to be able to view the core samples that came out of the 9 holes that were drilled in different sections of that area. You know what I'm talking about, right?
No.
Well, Randy, you know, you heard about Randy this morning. Randy was an engineer that worked on that. And Randy was saying that you went down 420 feet, but you could not find bedrock. Did you acknowledge the fact that there are aquifers that run underneath that North Spur? Are you aware that the drainage is all the same portion of land where the slide occurred? Listen, I'm no engineer, I'm no expert, but you need to start having more empathy and putting faces with these numbers and these statistics. Newfoundlanders and Labradorians are paying a dear price for this. There are people suffering right now for this project. Senior citizens, it's all hooked into the same thing. You say there's a detachment between Muskrat Falls and what's happening in this province. You put this province, Nalcor has put this province on its knees, and there are people begging to have some sense of purpose in this province. And Muskrat Falls has been the ruination.
What is your question?
Well, you got my question. You heard my question.
Have I considered?
You
yes.
can talk down to me, but
no.
listen.
Let me answer the question.
Condescending. Your attitude is very condescending to a lot of people who made comments here.
Okay, thank you for your question.
And I find it extremely rude. Question is, can you reassure those people downstream that their lives are not in jeopardy?
Yes.
Thank you.
Can.
Yes.
Well, I hope you can face them.
I have. I've go up to Labrador. I was up there in December, talked to the circle.
I was watching.
All that work has been done by many highly qualified geotechnical engineers, many of them. All these factors have been taken into account in design. I've talked about some of them. The single most important thing in what we do is safety, not only for our workers, for the public, including the people downstream. I've been in this business 40-odd years. I've never put people in danger. I'm not doing it now. Why would I? Why would I knowingly put people in danger? And by the way, I didn't start this project.
I didn't say you did.
I came in here to help out.
You're responsible for it now.
Yes, I'm responsible for it now. It's totally my project now. And everything that all these things that were asked, I've investigated and satisfied myself. And my responsibility is to do what I can.
You're aware people are sleeping in your beds with life jackets underneath at night?
Look, people, yes, people live in fear. I can't help them. All I can say is everything reasonably to be done to protect their safety. Rural experts have worked on this. I personally see no danger.
So we have time for
greater danger of being killed by a plane falling into the sky than you are flooding from the North Spur.
So we have time for 2 more questions. There's 2 people up there, Sean and some other right there. Okay, thank you.
Thank you, Mr. Marshall. Am I on? This is not so much a question as a comment, but I think comments are justified, aren't they? We listened to you for an hour and a half. I have about a 1-minute comment. You told us to stop looking at the small things, the minutiae, but look at the big picture. But it seems to me that you're looking at the minutiae. That is, you've told us that you've done your job, and I don't doubt that you have. You took the boondoggle and you brought it into order. You did that, and you've done it safely, and you brought the project to its completion. But isn't that just the minutia? Isn't the real issue here a couple of things you haven't mentioned? Environment, the erosion of Newfoundland democracy. I mean, at its absolute lowest, right? I mean, this project, if anything else, was a complete disaster for democratic process in Newfoundland and Labrador. It brought us to a point of hunger strikes a year ago, for example, absolute confusion, blocked down on information flow to the point where nobody really knows what's going on. It's complete, and we all have to come in here and have you explain the project to us after it's gone ballooned to what, $12.7 billion, more or less condemning everybody in Newfoundland and Labrador to a future of deep economic uncertainty. These are the issues. That's why we came out, not in order to hear you explain how you brought the boondoggle to order, but to understand something of what's going to happen, to example, for the Innu and the Inuit, whose lives are forever changed by this. How did we get here? And what are we going to do to reconstruct our faith in democracy in Newfoundland and Labrador after something like this can happen? You speak about how we needed to replace Holyrood. Certainly we needed to replace Holyrood, but did we need such a dam to replace Holyrood? And exactly whose coffers are being filled by this project? It's certainly not the people here, well, perhaps it's people in the room, I don't know who these people are, but the people in this province, you know? So, I mean, these are the issues that I thought we were going to discuss tonight. Instead, we heard that you've done a good job. Well, congratulations.
Thank you, Sean. There's one more question here.
About that. In 2040, I noticed a lot of your charts go to then, and that's when the contract with the Upper Churchill ends. I'm wondering if you can do a bit of crystal ball gazing and tell us what you see happening in 2040. It's right around the corner as far as I'm concerned, and do you see any possibility of something like an east-west grid, Churchill Falls, Muskrat Falls, all tied into a North American power distribution source?
Finally, a question. Thank you. Yeah, I think, well, that's the other thing that wasn't really considered here. You look at, a lot of this stuff was done on analysis for 40-odd years. It failed to recognize in 20 years we have all this power, 20-odd years back from the Upper Churchill. So really, it should have been, all analysis should have been done until we had access to the Upper Churchill, and a lot of power and capacity. When I spoke at the Eastern Canadian Premiers, New England Governors back in August in PEI, and we had the premiers from Quebec there, Newfoundland, and people from the Northeast. And I spoke about this and said, look, in 2041, 5,500 megawatts of power is going to have to be repriced. That we know. And let me tell you, it's going to be priced a hell of a lot higher than 0.2 cents a kilowatt hour. And that's going to change the whole dynamics in the Northeast. And when you look at Quebec, people don't really understand even today that Quebec has a lot of energy. Like the problem we got here, a lot of energy and no capacity. You're running out of capacity too. And they can't afford to lose 5,500 megawatts. So there has to be discussion long before 2041, because as you see here, it can take a decade to build a new hydro plant. So 23 years now away isn't that long. There will be discussion. There has to be discussion.
Sorry, is it reasonable to assume that we are in talks now at some sort of departmental level with Quebec for what is right around the corner, really?
I'm not aware of any.
Okay, just before we thank Mr. Marshall for his frank discussion, just so you know, if you're interested, he's gratefully agreed to allow his presentation to be available for you tomorrow. So we will send this out on our Twitter account tomorrow, and you can look at it, and we'll put it on our website as well. And just so you know, this has been taped, so we will have this available on our website within 3 business days or something like that. So we'll let you know about that as well. So, and I want to thank Mr. Marshall for his enlightening talk. And whether you agree with talks or comments that people make is kind of irrelevant. I mean, the issue comes down to you need to have a discussion as part of a democratic process, Sean, right? So, so we don't have a problem with what was discussed here tonight or what the questions were either, for that matter. So thank you for coming, and drive safely at home. Bye.